Cool. So without further ado, let me bring in Adam. Hey, Adam.
Hello. Look at that. There was applause.
We actually have like some fake applause somewhere, no?
That's fancy.
Yeah. Yeah, we have like a very high profile operation here.
Obviously.
We're just using like the screen in front of us to create light, proper lighting.
Yeah.
So that was like this today's new innovation in our studio.
It's a good move.
Thanks for coming, man. It's really,
yeah,
really
my pleasure.
So I think what we like to do is kind of like start by getting some early as you want background, kind of like I'm always super curious to hear those stories and journey.
Yeah, I mean, look, the short version is that when I was a kid, I liked bulletin boards, if you remember bulletin boards. And then like bulletin boards were the coolest thing about computers, which then sort of leads you directly to the internet, at least in America.
Did you have like were you owner of like a BBS?
Yeah. I ran my first bulletin board when I was like 8.
Really?
Yeah.
Oh my God. I love those. I was
totally
into that. I was totally into that.
Yeah, I'm a little upset that they're gone. Like every once in a while I still like fire up something and go play Trade Wars, you know? And yeah, so I mean that led me. Sorry, what?
No, it's gonna be a new retro thing soon. Don't worry.
I think it probably already is.
It probably already is. I'm sure there are.
Yeah.
Now you got me to like go search for something. Okay.
Yeah. So yeah, I like, but that led me to being a systems administrator and sort of the early eras of the internet. And then, my career has sort of just followed the problems that have happened as we've grown bigger and bigger. Like initially the problem was how do you get people on the internet? Then the problem was what are they going to do when they're on the internet? And so we all started building applications. People could do stuff on the internet. And then we were like, hey, wouldn't it be great if what you did on the internet was hang out with other people? And so then it was like Facebook and like social media. And, so at each of those stages, there's been some kind of, and then we were like, shouldn't all of the enterprises all over the world, shouldn't your bank work just like the internet works? And so like over and over and over again, we've just keep finding interesting new problems. And so, yeah, my career is mostly just paralleled those problems where it's been like, okay, whatever is interesting and is sort of next, then you sort of tackle how to figure out how to make it work. And yeah, for me, that's mostly looked like operations and systems administration stuff. And it turns out what I like to do is I like to write software for those people because that's kind of who I am.
The inner BBS child.
Yeah, the systems administrator, the operations person, both with Chef and with System Initiative, it's like I write software for people who build infrastructure or who think about applications or, but I tend to be thinking about the technology that runs the technology as opposed to like, I don't build like StreamYard,
Yeah, I see. Totally. Of course I know. And
yeah, because you were here and you build Wing and you know exactly what I'm talking about because you build tools for people who build tools, who use tools. Yeah.
Exactly. Yep. But I have to say it's pretty interesting because I also started programming in the kind of late 80s, 90s.
Yeah.
And I was always very attracted to like library and framework design and object-oriented programming and kind of like basically constantly thought about the applications and how you're designing applications, which is really I've never ran a BBS board, right? Like I used to connect to some, but I've never. So it's interesting, very interesting.
Yeah, it just depends on like I think it's just it's the same part of your brain. It's just lit up in a slightly different way. Like one version of it, it's like, how are we connecting all the things together and figuring out how the pieces work more under the hood. And then the other one is like, how do I build something that people can use, and like, I was doing that too, but it was mostly like, generating characters for Dungeons and Dragons or whatever. But where I was spending most of my time was like actually figuring out like how it worked. Cause that's what I liked. I liked how the insides worked, And
you said that you were drawn to the operational side. Writing software for that, I think like early on, it wasn't so much software. I think you probably are one of the pioneers of writing software for operations.
Yeah, I mean, it was always software. We just didn't talk about it that way. So, like if you were around, if you've written like a send mail configuration file, especially before M4, that this is like your audience is like, what's he talking about? And it's like, this is the way that like
This
email.
entire conversation is basically not for our audience.
Yeah. Cheers. Yeah. I'm such a good guest. Like SendMail was like had a very incredibly complicated configuration syntax that allowed you to really tersely define how different mail transport formats interoperated. So you could like translate between email and like pack mail to talk to a bulletin board or to be thrown over UUCP. And like it was great at that. It was incredible, but it was so hard to understand. And so if you were a person who mastered SendMail, like the book for SendMail was this big. Like, and it was every ounce as complex as learning how to program in C. Like I still have a copy, like the KNRC book is right back there. It was like this big. And like which one is programming and which one's not,
Yeah.
Like I think when you think about it from the point of view of systems people, like that separation was actually sort of at the root of what brought us to DevOps, because we had sort of convinced each other that there was a delta there. And the truth was that there wasn't a delta there, that in fact, all of us were programmers the whole time. The only difference was what kind of language are we working in? What kind of problems are we trying to resolve? And how do we solve them? But we had created this artificial gap between systems administration and operations folks and software developers, which, to be frank, usually had software developers at the top of the pile and systems administrators at the bottom. And for me, that's one of the reasons I started building great tools for systems people, because I just, that was always bullshit. It remains bullshit today. If you're a great operations person, there are skills that you have and things that you can do that a fabulous software developer who doesn't know anything about how operational things work can't do. And in both cases, you're software developers. You're writing software. They're just different kinds of software for different purposes.
So interesting, because I think that this is why I built a CDK, right? And a CDK comes from that exact way of thinking. Is like, we're all developers, everything is software. There's no reason why infrastructure doesn't have to be treated the same as any other software piece that's part of the system.
Yeah.
And I still think so, right? Like I 100% agree with you that everything is software, but
yeah,
I do think there are different problem domains.
Totally.
I think different software engineers deal with, different software engineers in the different layers deal with a very different problem domain, right? Like
Totally.
Developers who build the applications, they're focused on the problem domain of the business, right? Like that's their world, and that's the mental model. That's the problem solving they're doing is at that level. And engineers that are working on the infrastructure side or on the operational side and the platform side are dealing with a different problem domain. That's how I see it. So I think
and I think you're
not about whether those are developers or not, or those are not, because I 100% agree.
Yeah, I think you're. I mean, you're manifestly correct, right? So it's difficult.
That's how I like to be correct, basically.
Yeah, I mean, however, here's the rub, I think, which is that the focus. I think we got the focus a little off. So if you looked at the first round of DevOps tools, we really embraced the idea that what we were all doing was automating the way that we worked. So we were looking at the way we worked. So we're looking at the way application developers worked. We're looking at the way operations people worked. We were putting those people together so they collaborated better and more. And we were trying to automate that process so that collaboration was made easier. And in the end, you'd be able to ship software faster, more stably, more reliably, more securely, right? I think what we learned is that the shape that we chose to automate was the wrong shape. Because it's not like any individual tool was a bad tool. They're not. They're all actually kind of great. But if you look at the results people are getting in the enterprise, like one of the reasons there's an opportunity for Wing or for a system initiative is that if you go talk to people about how they feel about the end results, they don't love it. They're like,
100% agree.
They're having a bad time, and
right. They're
and
like they feel something's wrong, but they don't really know what.
They can't really tell you what it is, right? And there's a really great Bill Hader video, which where he explains that like when you're doing comedy, people can point out why something isn't funny or why it's not right, but they're usually right that there's something wrong in that zone, but they're wrong about the solution. Like all the time. And this is basically the same here too. It's like, yes, there's a problem. We know there's a problem. The question is like, what are we going to do about it? My supposition is that the problem is systemic, that the shape of the way we decided to work, what we wanted, the properties that we knew brought about good outcomes, started with collaboration. They started with how do we bring those application developers and those people who have operational expertise closer together so that the work they're doing feels more holistic and gets delivered together in one move. And then we made a bunch of software to try to do that by just automating the way that they worked nearby each other, you know? And we were like, and, you know, you can see it in the way we collaborate.
Examples? Can you give some examples?
Yeah. Like the normal point of collaboration in most people's DevOps workflow is the pull request review. And it's actually right there in the name. It's code review. It's not code collaboration. It's code review. Like somebody does it and then you tell me if it was good or bad, right? And I think when we think about the separation between application developers and operations folks, the truth is the end result is the same. Like if you remove the operations people from the equation, there's nothing for the application to run on. If you remove the application developers from it, then it doesn't do anything. And so there's no point in having infrastructure. It's just computers, which are, I guess, fun, but not particularly useful. And so
only the fun.
I'd be surprised all the companies that are selling their internal infrastructure to other companies.
Sure, right. Yeah, exactly. All, to do nothing. So like, I think so the example there that I give is that like, when you think about how we work, like asking a developer to go read a bunch of Terraform to better understand what's about to change for their application as it deploys is not a good loop. It's not good for the application developer. They don't understand it. They don't understand how the infrastructure works. They don't understand the impacts of the plan. The feedback loop is really long. You know, maybe it might take you 30 minutes to know if you got it right or wrong because it has to like churn through the actual AWS to do it. The plan tells you lies, all kinds of shenanigans you have to go through to sort of make that stuff work. And those foundational choices that we made early on that said, hey, the way we're going to represent this infrastructure is as code, or we're going to break the platform piece separate from the application deployment piece or separate from the way that we do these other pieces. Those things are actually, I believe, what's actually causing the bad outcomes. It's not a technology question of like Terraform sucks, therefore the outcomes are bad, or, you know, whatever, Jenkins sucks, and that's why your pipelines are not good. Like, it's not that. It's actually that the way we've assembled the whole shape of the workflow is wrong. And we need to change that workflow if we want better outcomes. And I think one of the things I like about Wing is that, you know, whether you phrase it that way or not, I think there's this recognition that there has to be a different user experience to solve this problem. That like changing the workflow of the user experience is the way that we're going to figure out what's better. And I think we're both making bets like that say, hey, let's fix this user experience, and that will go a long way in getting to better outcomes.
So how do you envision, just describe like what would be the user experience of someone, the team, you know, the workflow for teams using System Initiative? Like how would that
be? So we think about it as essentially, we took a long time to build System Initiative. So it took us like 4 years. So we've built a lot of different things that we've been trying to figure out how to make it work. So we didn't just build one thing. It's not like we started with the right vision 4 years ago and then got there. It was a lot of wandering in the woods because our goal was to really change the outcomes. So where we landed was that in order to fix the biggest problem, which is feedback loops and inference. So the two biggest problems we think are how long it takes to understand if you've done something, if it's right or wrong, And then right or wrong is dependent on your environment. So like it's one thing to say that a configuration is wrong canonically. It won't work, right? It's another thing to say it's wrong at Citibank, or it's wrong at Ford, or it's wrong at Facebook, or it's wrong at Wing. And you need to be able to do both. And you need to be able to see that feedback in as close to real time as you possibly can. So how quickly can we know that that's right or wrong? So that led us to essentially building a simulator that allows you to model what's possible and then say what are the rules that that need to be applied. And rather than actually doing it, if we make the model high fidelity enough, then that model can tell you in real time that you're right or wrong, and that it meets your policy or doesn't. And then the other piece is you need to be able to think about how configuration gets inferred. So if you think about how much we have to repeat a single piece of configuration across multiple layers of the stack. So a great example I use is, how do you know what port an application is running on? So you put the application in a container, you decide it's running on port 80. Now you want to deploy it to Kubernetes. So we need to thread that port number through from the Docker container to the Kubernetes deployment
to the values, to the Helm chart, to the
Helm chart, to the ALB that's in Azure, to the right. And the syntax there is also different. So the way you express it in Docker is like 80/TCP, but that's not how you express it in a Kubernetes manifest, right? You deploy that's got a totally different shape, which is different yet again from the shape that you express it somewhere else. So it's not only that value must flow, it's that value must be translated to semantically match across those layers to the places it needs to match. So we think about that simulation as essentially a gigantic graph that has multiple layers in time. And at each point in the graph, which is as low as like a single property, what you're doing is running a function that generates a value. And then you can have essentially think about it as like sockets that will then flow that data through, where you can translate it, you can change it, you can infer values, right? The side effect is that you can really quickly compose those models together, and they'll keep their configuration correct, and then they'll generate the code from the model. So rather than starting as infrastructure as code, where you write code, the code defines what the world looks like and you do it. Instead, what you're doing is defining a model, and then the model derives what the right code would be for whatever the domain is, and then keeps it up to date because it understands what to do. And then the last bit is you have to track the real world state of the resources that get created. So if there's any, sometimes you're talking about concrete things like I want to manage an EC2 instance, or I want to manage a Lambda function or whatever. And sometimes it's abstract. This is my application, right? There's no such thing as the application. The application is like a conglomeration of all the stuff it needs in order to run.
Of course.
So how we think about it is you model all of those things in System Initiative. And then when it comes down to those concrete resources, we're also tracking those concrete resources over time and then letting you reconcile between them. So saying, hey, your model said that this resource was supposed to look this way, but it doesn't. And do you want to change it? Do you want to update that resource? Do you want to, and that maybe that operation is whatever it is, however the domain models it. Or it may be that the resource is actually correct. Somebody was troubleshooting, so they logged into the AWS console and they clicked a button that fixed a bug. So instead of having to destroy that or have your automation turned off, which people do all the time, right? Oh, we're firefighting. Turn off Terraform, figure it out, fix it, then go write it in the code, then redeploy it.
Move away.
Exactly. Here, we would essentially just let you change it however you wanted to. And then we would just look at the resource and notify you in the UI to say, hey, these two things aren't in sync. One thing you could do is change it so the resource is in sync with the model, or do you just want to update the model? And then problem solved. So, that's System Initiative in kind of in a nutshell. And the core of it is that in order to fix what is wrong systemically, we needed to change the way we think about modeling the system altogether.
Yeah. So when you say who's the persona that you target to use System Initiative? Is it the DevOps engineer, the the application engineer, both?
Yeah.
What's the flow like?
Yeah, I mean, it changes a little over time, right? So today, system initiative is new and like rough around the edges. And so who it's really ready for today are just innovative DevOps engineers who heard the description I just gave, and they were like, that sounds fucking
fell
cool.
in love and fell in love.
Yeah, and if you want to come hang out and it's open source, you can come hang out with us and build it. Like, let's go. So it's ready for those people now.
You guys just open source it, right?
Yeah, we open sourced it last week. All the software is open source. Every line of it's open source under the Apache license. Always will be. Yeah, so that's what it's really. That's what it's ready for today.
Go ahead.
But eventually it'll grow. So because you have all this data in the model, and because it doesn't matter, you can model anything you want. Like it will eventually grow to do all kinds of stuff because there's all sorts of valuable information in there. What will change is the interface. So if you think about the jobs that we do and how we collaborate, there's not one universal interface that makes sense for every job that's involved in that full cycle of how we get an application out to production. So, the way that a DevOps engineer interacts, they're caring more probably about the infrastructure. Application developers care more about the application. They probably care more about things like deployment. They care more about test coverage. They care more about all kinds of other information. So over time, the interface grows and changes to sort of accommodate different personas.
This was extremely fascinating because I feel like we actually, in a sense, Wing is building this exact same architecture, right? It's basically you create a model of your cloud application, you'd model all those resources and all those nodes, and each node has like relationships to other nodes, and some code that represents their behavior, and also a composition model where you can like take multiple of those resources and create higher level abstractions from them.
Yep.
And then you synthesize configuration, right? Like there's basically when you're compiling a Wing program, you're going all over this tree and you're synthesizing the configuration. It could be anything.
Totally.
So I think like there's lots of like basically the same architecture for the systems, which is really interesting to me.
And I mean, it makes sense, right? Because if you sort of think about the history of our space, there's only so many threads to pull on.
Correct.
And so it's your recognition and my recognition of the same sort of feedback loop problem and the like abstraction and synthesis problems. Like those are the problems. And if you're committed to solving them, like the architecture
you end up with a simulator.
Yeah, you end up with similarities, and what's like the differences are interesting and meaningful, but it's not surprising to me that there's more similarity there than there is difference, because if you're thinking about like Joe at Pulumi, for example, I think has had a very similar point of view about how Pulumi might have evolved in a different universe. Pulumi could have looked a lot like Wing, right?
Yeah.
And I think I'm not sure that the universe was ready for Pulumi to look like Wing, for example. So like
totally. I mean, that's when I released the CDK, right? Like at that exact same month, basically.
And so you wind up in this interesting spot where
evolution of designs, evolution of layers and abstractions, right? Like it's kind of like this organic process.
It evolves like art. It's always, we're in conversation with each other over a long period of time on the art of how this can work. Like it's art. Like I learn from you, you learn from me, we learn from Joe, we learn from Mark Burgess, from Luke, and like there's this huge long line of people, and like you take those inputs, and what it comes out as is art.
Yeah.
It's a good sign for both of us that architecturally it wound up being roughly similar, because what it means is we're probably right that art is somehow compelling.
More right. Yeah, a little more right.
We're more right than we were before we had this conversation. Yeah, because and I think that really just points to this need for this like second wave of DevOps tooling. Like the thing I most want to see, like, of course I want System Initiative to like be the biggest business I can turn it out to be, and I want people to love the product, and I want all that stuff to happen. But like, I also really just want to see all the different ways people will build new stuff when they realize that they can build new stuff again, and that changing some of those fundamental building blocks is actually quite achievable and can really be different in the way that like the outcomes can be really different than what we've had before. And, you know, yes, it's riskier because you might be totally wrong. There might be things that you don't understand, like, but I don't know that we need another like a slightly better CDK. I just don't. But what would it do? Like, we've pushed on that angle for like a while, you know.
I agree.
And so we need people pushing on new angles if we want to see like really outsized changes.
And I feel like I want to say hallelujah.
Yeah.
No,
right.
I totally. It's also really, I love it. Right. Like I agree. This is kind of like this beautiful thing that happens. I actually had the same experience with Pulumi. When we released the CDK, the same month Pulumi released their beta, and I was like, "Oh my god, these guys are." What happened? Like, were they in the room? It felt really odd, to be honest, right? Like, it was the first time I felt this kind of like you get to the it's all about problem solving eventually. And I feel like we're trying to crack problems. This is what we do, right? We're trying to kind of solve for many constraints that are like accumulating over time. And
you came from similar backgrounds. You were both
geeks in the 90s.
Well, but you and Joe, like I think in particular, have like a lot of background overlap, right? Like language design, like there's like you're very like have really similar backgrounds. But like,
I also feel like I learned a lot at Microsoft. You know, I spent some time at Microsoft, and I feel like there was something about Microsoft. There is something about Microsoft's proficiency in like designing developer tools and frameworks and libraries and API design and class library design. And I think that's totally correct, right? I feel like that's
yeah. I mean, as an outsider, I always felt like the people that I've known who were great at Microsoft, like part of what made them great was that they were very willing to like go to the fundamentals if they needed to. They were very willing to be like, well, we could write a new programming language. Is that what we need to do? Like, do we need to write like whatever it is they needed to do? They were willing to go do it in a way that like other organizations often will hesitate. They'll be like, well, maybe that's too hard or it's too complex or we don't understand it. And like Microsoft does, I think, have a pretty solid history of finding a way to do that. And I think, you know, hopefully now as we sort of build this second wave of DevOps companies, like if we can figure out, you know, we have more in common. We're more alike than we are different. We have more in common than we don't. And I think what we need to figure out how to do is like, how do we stay in conversation with each other so that those things do get pushed forward and those good ideas do come out and we can express them to the world in a way that's like, hey, we did actually learn that like that there is something really important about the idea that what we're doing is essentially building simulators that then like generate the configuration or generate the outputs or synthesize the results. Like it's just an interesting idea. And it's one who I
think an area we can definitely talk about collaboration is specifications, you know, like open specifications for different layers, because I do think that there are, I do believe that, different problem domains and different types of engineers, they like to use different tools, right? Like they have a different, their brains are wired differently. And I think like it's really interesting to see those two solutions kind of like coming from, two different paths to very similar results. But I do think that there is something about the interface, right? Like what interface you're using. And like you said, different people would want different interfaces. And I think it would be really interesting to try and collaborate.
Yeah, I think you have to think about, as we build and we do more, like, it took us a long time to build System Initiative. I know it took you a long time to build Wing. And
not as long.
yeah, yeah.
Yes.
Um, but like, I think you know, it's going to take the people who come after us less time. Like
Yeah,
they'll
no, and
have us
also, and I
to
think
look at.
also acknowledging that there's an ecosystem, right? And every layer, there's always an ecosystem. And if the layer is
Totally.
well designed in terms of like collaboration around the industry, and it's usually about like specifications and standards. That's eventually the way you're able to create these like collaborative, this decentralized initiatives work together.
Yeah, for sure. I also think there's just a pure community building question, which is like one way that this goes as things happen over time is that, people love what they love. They love Wing, they love System Initiative, they love Pulumi, like whatever it is that you love. And the way that folks like us relate to each other informs the way our communities relate to each other as well, right? So, if we like each other and we like respect what we're doing for each other and we respect the way that each other are approaching the problem, then our communities become communities that respect each other and respect the way that they approach the problem, and like whatever they can talk about where they disagree or where they diverge in ways that are kind and sort of move the needle forward for
Yeah.
everybody. And
Hallelujah. We need like
that's the way. So
absolutely.
So
Absolutely.
maybe let's kindly discuss a bit how where we diverge. So far, we've just talked about.
I think, do we have
similarities.
time? I think we might need to like get Adam to. Would you be interested in? Yeah, I'm sure we'll keep in touch, and I
yeah,
think
we can
we're
talk about.
over time almost.
Yeah, I'd love to. Of course.
So we can discuss divergence in
Oh, definitely we should.
in a future episode.
Yeah, I mean, I think like we could absolutely talk about it because it's not like we haven't thought about it yet. So
Yeah.
I'd be more than happy to talk about how we diverge.
That's what's gonna be really interesting to our viewers.
Yeah, for sure.
Cool. Any parting words?
No, I mean, thanks for having me. I appreciate it. Yeah, looking forward to it.
Thanks for coming, man.
My
It's
pleasure.
really a pleasure, and I'm a fan of the way you talk about our industry and what we're doing. And I wish I had more. I don't know. I wish I was better at that.
You seem
But
pretty good at it so far.
I'm not really. But I knew it's going to be a really fun conversation. I love all the anyway the shared value system. I think like
For
that's
sure.
really fun to see, and looking forward for like collaborating.
Definitely. See you later. Thanks.
Hey, see you later, man.
See
Bye
you.
bye.